Okay. So how is soap formed, or how do we make soap, right? Can you hear me?
Yes.
Right.
Yes, sir.
We make soap by oil or from oil. It
Yeah.
can be mustard oil, coconut oil, groundnut oil, palm oil, basically any vegetable oil, right?
Yes. Yes.
We heat the oil and then we add sodium hydroxide to it.
Okay.
And in this process, soap is actually formed, but that is not in the form of the soap cake.
Okay.
That is in the solution form, I can say, right?
Yeah. Yes, sir.
To this we add small amount of the sodium chloride, and then we can get the soap as a solid, as a soap cake.
Okay, sir.
Then we cut it into pieces. It is very soft by that time, and in this process we can give it any shape, any stamping on it, whatever we can do on it, right? And
Yes.
then we get the soap. This is what we
Oh,
call, in industry we make it like this.
yeah.
But what is the chemistry behind this? Oil contain triester. Oil contain triesters.
The
What is this?
triester formula is?
I'm telling. This is the R part.
So you're not sharing your screen.
Oh, I'm sorry.
Oh, it's
The
fine.
whole thing went gone wrong. Okay. I was
No,
telling.
I understood it, but yeah. Okay.
It's okay. You got it now. I was telling this thing,
Yeah. Yes, sir. I got it.
and I was writing, and I was thinking that you are watching. Anyways, you got it now. We boiled the oil with the sodium
Yes.
hydroxide. We get the soap in the solution form, and then we add sodium chloride, and we get the soap as a solid, right?
Yes, sir.
What the chemistry behind this is, the oil contain triesters. This is the triester where R is a long chain carbon atom. Let it be C17H35,
Okay, sir.
or it can be C18H37, right?
Okay.
Basically long chain. R is long chain here. When it treated with the sodium hydroxide, right, the cleavage takes place from here, right? OH goes with the CH2OH, and it gives rise to glycerol.
Yes.
This is the glycerol, and three molecules of the RCOONA. I'll write it like this: RCOONA, where R is a long chain carbon atom. That is C17H35, right?
Yes, sir.
This is the soap that we get along with the glycerol.
Yes.
This is separated now, right?
Yes, sir. Yeah.
The soap, the glycerol is separated, right, from the main soap.
Yes.
And glycerol has its own usage. It is used in medicine, it is used for many other purposes, right? But soap is taken out. Have you ever seen any commercial soap that says it contains glycerol? Glycerine.
Yeah. Yes.
I think that, what is that name of the soap? Commercial name.
Pears or something.
Pierce, yes. That
Yeah.
transparent soap. Hmm?
Yes. Yes.
That contain the glycerol along with that. Right,
Yes.
according to the some cosmetologist, they say that it makes make the skin soft, right?
Yes.
So this is the soap here we're getting here. So soap is nothing but it's a sodium salt of higher carboxylic acid. Sodium or potassium, both. It can be sodium, it can be potassium,
Okay, sir.
salt of higher fatty acid.
Okay, sir, got it.
Right. In your
Yes.
book, directly they are writing from here, soap is sodium salt of higher fatty acid.
Yeah.
Right, but I had told you why do we call it higher? Why do we call it as a higher fatty acid? Means it's a long chain carbon atom here.
Yes. Okay, sir.
Right. So I can say, if I represent the molecule like this, 17 carbon atom, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17, and then we have a COONA.
Yes.
Right, this is called as a sodium stearate, and this is a that khaki color sabun, brown color soap. Have you ever seen that? Brown
No.
soap, brown, that is used
Yes.
for cleaning the clothes only.
Okay.
Have you ever seen?
Not the brown, the blue ones I've seen.
Blue is Rin.
Yeah.
No, I'm not talking about that Rin. I'm talking about the uh, brown color soap. You are not seeing?
No, sir, I didn't see.
Okay, fine.
Yeah.
Mm, okay. Ask your parent; they may help you to see it, right?
Okay. Yeah.
Because it is easily available in the market, right?
Yes.
Most people use that soap only, right? That
Okay.
is very cheap one, right? Rin is very costly otherwise.
Okay.
Rin is very costly otherwise. So this is a soap now. Got it now?
Yes, sir, got it.
Okay, now. This soap, when dissolved in water, if it is dissolved in small quantity in water, it just dissociate into its ions.
Okay.
So we say in small concentration, this behaves like an electrolyte only.
Yes.
Am I clear?
Yes.
It behaves like a electrolyte only. It does not give any lather, no foam formation, nothing.
Okay.
Right?
Yes.
Have you ever observed this, that if you add small amount of soap in water, it does not give any lather,
Yeah, it does not.
right? But if
Yes.
it is added in more quantity, after certain concentration, what happens now? There is a particular concentration above which the froth formation take place. That minimum concentration is called as a CMC. We call it the critical micellization concentration.
Yes. Okay, sir.
It's a minimum concentration above which the micelle formation takes place.
Okay. Yeah.
It is a minimum concentration above which the micelle formation takes place,
Takes
right?
place.
And
Yes.
there's a particular temperature also above which the micelle formation will take place, and that is called the Kraft temperature.
Okay, sir.
If you dissolve the soap in water below the Kraft temperature, the froth formation will not take place. So
Okay.
these are the two conditions for the froth formation, micelle formation, right? Number one, there must be some minimum concentration above which the micellization will take place, and is called as CMC, and the temperature must be above Kraft temperature, right?
Okay. Yes.
Now, what is micelle? How exactly the froth formation takes place, and how it cleans the cloth? The whole mechanism I will not discuss now, right?
Yeah.
This R is long chain carbon atom. So I can say this is long chain carbon atom. At the end, we have this COO negative ion. This part is polar part. It is a polarity, negative charge. This is
Oh.
attracted towards water. So we call it the hydrophilic part.
Yes.
Hydrophilic means attracted towards water.
Yeah.
attracted
Towards what?
towards water, right? Getting me?
Yes.
And this
Yes.
long chain carbon atom is repelled by water. This is called the hydrophobic.
Yeah.
Hydrophobic means repelled by water,
Yes.
right?
Yeah.
At the CMC level, what happens here? Suppose you say that this is my bucket which contains water, right? This contains water here.
Yeah.
The molecule, the soap molecule, the polar part is towards water and non-polar part is away from water. They make it a spherical cluster, right? Negative part, the polar part towards water, and the non-polar part moves away from water. This spherical cluster what we get is called as a micelle.
Yes.
We call that as a micelle.
Nice.
Understood now?
Yes, sir.
So many large number of micelle when aggregate together, they give rise to froth.
Yes.
Understood now?
Yes, sir.
Till now, any doubt? Under what condition froth formation take place? How the froth formation takes place? What is the hydrophilic and hydrophobic part? All these points are clear.
Yeah. So can you repeat the temperature for which this?
The temperature above which the micellization takes place is called as a Kraft temperature.
Craft temperature. So there's no specific temperature.
And, for different type of soap, there are different temperature,
Oh, okay, sir.
right? The soap that I'm talking about, the sodium stearate, its Kraft temperature is 4.2 degrees Celsius. But the Rin soap has a
Okay,
craft
sir.
Rin soap that you have, their craft temperature is maybe slightly different, right?
Yeah.
Right. I'm searching here. What is the craft temperature? CRAFT craft temperature of Rin soap, because we are using the Rin soap. So, I don't think they will give you the value for the Rin soap,
Okay, sir.
right? But the definition is very clear. The minimum temperature at which the ionic surfactant that is making some, right, that forms a micelle formation, right?
Yes.
Craft
Yes.
temperature for the soap is 310, right? And CMC is 10 to 3 molar. Okay.
Yes, sir.
Now, let us go to the topic that is the cleansing action of soap.
Yes.
Cleansing action of soap, right? How soap cleans the cloth. Basically, the purpose of using soap is to remove the oily dirt stuck on the
Yeah.
cloth, right?
Yes.
This is a cloth, and this is the oil that is stuck over the
Cloth.
cloth. And when you dip it in the soap solution, you should see that the soap molecule is like this, polar and non-polar here, right?
Yes. Yes.
This part is polar and it's a hydrophilic. Got it now?
Yes.
Hydrophilic. Hydrophilic means what?
It is attracted to water.
Good. And the other part is hydrophobic. What do you mean by that?
Sir,
Hydrophobic.
hydrophobic, it moves away from the water.
It moves away from water. The one that
Yes.
is a hydrophobic is a lipophilic.
Yeah.
Lipophilic means that is attracted towards the fats.
Yes. Okay.
That is attracted towards the fats,
So
lipids.
does this the soap contain lipophilic or?
Yeah, the long chain carbon atom is nothing but a lipophilic part.
Okay, sir.
Right. And the hydrophilic is a lipophobic.
Yes.
Lipophobic.
Yes, sir.
Understood?
Yes, sir. Got it. Yes, sir. Got it.
Okay. So the soap lipophilic part goes inside the soil and the hydrophilic towards the water.
Yeah.
And the water molecules, these are water molecules. Do you know that these are polar molecules?
Yes.
These are polar molecules, right?
Yeah.
So this polar molecule, the positive part attracts these particles towards itself, right?
Yes. Yes.
And it pulls the oil along with the soap particle in the aqueous solution.
Yes. Okay,
So
sir.
what happens now? The cloth is here, right? But the
Yeah.
oil particles comes out like this. In this, what happens here? The polar like this.
Yes. Okay. Got it.
It means the oil dirt has come into the solution now.
Yes.
Any doubt till now?
No. So can you just tell the definition of polar? I will write it down.
Okay. Polar means what, right?
Yeah.
Suppose I say I have a molecule of the HCl, hydrogen chloride, right?
Yeah.
Out of the hydrogen and chlorine, the chlorine has more tendency to pull electron cloud towards itself, right?
Yes.
It is
Yeah.
not equally distributed, so chlorine is having a partial and negative charge and hydrogen is acquiring partial positive charge.
Yes. Yes.
Understood?
Yeah.
So I
So,
can
but
say,
how do we know which one has like more tendency?
yes. Normally the halogens have more tendency to pull electron cloud towards itself,
Okay, sir. Got it.
right?
Yeah.
So I can say the two poles are created here. One is the positive pole, other is the negative pole,
Okay, sir. Yeah.
right?
Yeah.
So we say the molecule is polar. So polar molecule means the molecule in which there is a difference of
Positive.
electronegativity.
So after the class is done, can you like, is it possible for you to share these notes?
Yes, sir, of course. I will share it just after the class, right?
Yes, thank
Or
you.
at the end of the class, I will share it in our conversation only, right?
Okay,
At the end.
okay, sir. Yeah.
Okay. Do you have any doubt now?
No, sir, no doubt.
This is the cleansing action of soap.
Yes.
Uh, you're in CBSE board, right?
Yes, sir.
I don't think there is a detergent topic in your syllabus.
No, sir, we have detergents. It's not given in detail, like nothing is given in detail that much, but my teacher, she did teach us about detergents. Like difference between soaps and detergents. Why does detergent not form lather in hard water like that?
Okay. So before that, I need to discuss about what is hard water and what is soft water,
Yes.
right?
Yeah.
What is hard water? Let us try to understand this.
Which has inorganic compounds.
Hard water is a water which does not give lather, which does not give lather with soap easily.
Why is that, sir?
Right, I will discuss just a definition,
Yeah.
right?
Yes.
Which does not give lather with the soap easily.
Yes.
The hard water contains calcium and magnesium bicarbonates.
Yes.
Calcium and magnesium chlorides. Calcium and magnesium sulfates.
Yes.
If any one of these are present in water, the water is called as a hard water.
Okay, sir.
Understand?
Yes, sir.
Any doubt till now?
No, sir, no doubt.
No doubt. Okay. Till now, any doubt? No? So,
No.
now what happens here? These salts, right? I am representing Mx for M for the metal like magnesium, or M for the calcium ion or magnesium ion, right?
Yes.
And X is the anion part, that may be carbonate ion or chloride ion or sulfate ions.
Yes.
This is soluble in water. Soluble in water.
Yeah.
It means this Mx in water dissociate to give ions. It means
Yes.
in the water I have a freely available calcium ions or magnesium ions.
Yeah.
Okay. Now coming to the soap part. RCOONA is produced from the soap, right?
Yes, sir.
RCOONA is formed from the soap.
Yes.
This concentration increases to CMC. CMC means what? Critical micellization concentration.
Yes.
Right?
Yes, sir.
And then the micelle formation take place, right?
Yes, sir.
But if these calcium ions or magnesium ions are present in the solution, they will combine with the soap molecule and they will form the scum.
Yes, sir.
They will form scum. It means the concentration of the soap molecule will not increase. It will not reach to the CMC level, and that is why the micelle formation will not take place.
Yes, sir.
Right? It can be calcium ion or it can be magnesium ion. They will combine the soap molecule and form scum.
Yes, sir.
Right?
Yes.
Understood?
Yes, sir.
And that is why in hard water, the soap does not give lather easily.
Okay.
Soap does not give lather easily.
Because it forms scum.
Yeah, because it forms scum, and the COO negative ion concentration, the concentration of the RCOO negative ion does not lead to the CMC,
Yes.
which is essential condition for a soap to make the micelle, right?
Yeah. Yes, sir.
So this is one problem with this soap. That is only one problem. That is, it is a
CMC.
it does not lead to CMC in the hard water.
Yeah.
Any doubt till now?
No, sir.
Okay. But this problem does not arise in the arise in the detergent particles, right?
Yes. So in detergent, the lather forms.
Yeah, even the hard water it gives lather, right?
Yes.
Right. So what is a detergent chemically?
It is a longer chain of sodium chloride.
Sodium benzoate.
Sodium benzoate. Okay.
Have you
So.
yeah, just give me a minute, please.
Yeah, sure.
Yes, hello.
Yes, sir.
Right. So what are detergent? You can write down detergent are ammonium, sulfonate or sulfate,
Yes.
salts of long chain hydrocarbon,
Yes.
containing 12 to 18 carbon atoms.
Yes.
Right?
Yes, sir.
This is a detergent, right?
Yes, sir.
The good part of the detergent is it can be used in hard water.
Yes, sir.
Number 2, it can be used in the acidic medium also.
Yes, sir.
They are more soluble in water and gives more lather, even in the ice cold water. More
Oh,
soluble, yeah. More soluble in water.
yes.
So
Okay, sir.
it produces more
Lather.
lather, and it can be used even in the ice cold water. It is a stronger cleansing action. It cleans better.
Yes. Okay, sir.
But there is a disadvantage also. Disadvantage of soap is it is non-biodegradable.
Okay, sir.
Degradable. It means if it goes in water, river or lakes, they pollute the water and the microorganisms cannot break them. It is not destroyed in the water by the microorganisms. Whereas soap can be easily destroyed. They are biodegradable.
Yes, sir.
Right? That is the only disadvantage of detergent.
Yes, sir.
Is the topic clear now?
Yes, sir.
Any other topic?
No, sir. That was the only one I was a bit skeptical about.
Right. Give me a second, please.
Yes, sir.
हेलो मैम आपने हमें अपना लोकेशन नहीं भेजा था कि मैं टीचर को एड्रेस दे पाऊँ मैथमेटिक्स के लिए. हाँ हाँ मेरे को लोकेशन दीजिए ताकि मैं टीचर को प्रॉपर लोकेशन भेज पाऊँ और आपको बता पाऊँ कि ही विल बी एबल टू कम और नॉट. राइट. तो अब डेमो कल ही लगा पाएंगे. अब तो लेट हो गया होगा. मैं मॉर्निंग में ओके. तो मैं मॉर्निंग 8 और 12 के बीच में भेजूँ. ओके. मेरे को अपनी लोकेशन एड्रेस दीजिए. एड्रेस प्रॉपर लिख. राइट. Yes.
Yes, sir.
So now I should give you some question practice, or what? What do you want?
So I will once again learn this topic and then we'll do question practice on this.
Okay. Right.
Now, that was the only one I had doubts, sir.
So we can end the session then.
I don't know.
You don't know. Okay. Okay. We are left with some 15 minutes for the 1 hour class, right? Let us discuss some questions. Let us discuss some questions and then we can end the session today.
Okay, sir. Sure.
Right. And our next session will be on which date?
Actually, it's tomorrow, Monday.
Actually, tomorrow. So tomorrow evening, what time we have class? I think it is.
We have it tomorrow morning at 5:30.
Yeah, morning. Yeah.
So can you take class tomorrow?
Pardon?
Can you take class tomorrow?
Yeah, I can take class.
Okay,
Right.
sir.
So tomorrow morning when you come with a doubts and plan what do you want to do. Otherwise, from my side, I have a lot of question bank that I can share with you and discuss the
Yes,
questions.
I will. I have few doubts. I'll write them all in like a big sheet and I'll send them and we can discuss.
Sure, that's better.
Yes. Okay, sir.
Today I had done the carbon compounds.
So, 1 second. I also wanted can you once acid bases and salts?
Mm-hmm.
Can we once get like a just a quick recap of that chapter? Recap in the sense I'll tell. I needed acid bases and salts. So the chloralkali process. Can we discuss it?
Pardon?
Chloralkali process.
Chloroalkali process. Okay.
Yeah, the entire thing, like even like bleaching powder, baking soda, how all of them are formed.
Hmm.
Can we do that now or?
Yeah, we can do right now. Wait.
Okay.
This is already done. This is after this we have topic of the salts.
Yes,
Na?
after this.
After this, so it is might be somewhere here. This is bleaching powder, right?
Chloralkali
Yeah,
process. Yeah.
Just before that we have. Right. Chloralkali process.
Yes.
What do you produce in chloralkali process? Sodium hydroxide?
Yes.
Right. So how do we do it? We add here brine. Brine means 28% sodium chloride solution. It means in the solution we have sodium ions, chloride ions, water has H positive and OH negative ion. And now we are passing current here
Yes.
through the DC current, right? Direct current.
Yeah.
So when you pass the current towards the negative terminal, the positive ion, sodium ion and the H positive ion both are attracted. So one possibility is H positive ion can gain the electron and become H atom, and two such H atom combine to form H2 molecule. One possibility. Am I clear?
Yes, sir.
Other possibility is sodium ion can gain electron and become sodium. Out of the two possibilities, the first one takes place, second one does not take place.
Yes.
Okay.
Yes, sir.
And towards the positive terminal, Cl negative ion and the OH negative ion both are attracted. Two phenomena can take place. Either chlorine will be losing electron, and two such chlorine can give you Cl2, right? Or
Yes.
it may be possible that OH ion will be giving electron to give water, oxygen and 4 electrons. Either chlorine will be liberated or oxygen will be liberated. But first take place the OH ion does not get oxidized.
Yes.
So here the chlorine is liberated and here hydrogen liberated. And in the solution we are left with the sodium ion and the OH ion, right?
Yes,
And
sir.
that's how we get the sodium hydroxide in the solution.
Okay, sir.
Understood now?
Yes, sir.
Any doubt?
No, sir.
No? So basically we are getting this thing, this equation, overall equation.
Yes.
That's it.
Yes.
Note it down. Okay.
Yes.
So chlorine is produced in the electrolysis of aqueous sodium chloride. This chlorine is used for manufacturing bleaching powder. Just read it. You'll get it. Okay.
Yes, sir.
Do you want to ask anything from here?
No, sir. No doubts.
Bleaching is CaOCl2, right?
Yes. Yes.
Okay. What is the use of the bleaching powder that I'm showing here?
Yes.
Oxidizing agent, making drinking water free from germs, right? Bleaching cotton line in textile industry.
Yes.
Okay,
Yes.
baking soda. Just read it, you will get it. But the formula for the sodium is a sodium bicarbonate. Okay,
Yes, sir.
and how it is produced, that is known as a Solvay's process. From sodium
Solvay.
chloride, yeah, Solvay's process. Note down this equation.
Yes.
And then sodium carbonate upon heating gives you sodium carbonate.
Yes.
Note it down.
Yes, sir.
Okay, understood?
Yes, sir.
Okay, so we end the session now, right? We'll continue tomorrow morning, 5:30.
Yes, sir, sure.
Okay then. See you.
Okay. Thank you, sir.